Kinematics. So remember, kinematics is our whole SPA thing. Displacement, velocity, acceleration. I will say though, in calculus, they actually don't use S very much for displacement. They either use P or they'll use X of T. So either those they could use. Right, velocity, acceleration. Remember when you go down, you're taking a derivative. When you go up, you integrate. Just keep in mind when you go up for integration, you lose time. Right, you get rid of that one time on the bottom. When you take the derivative, you actually you divide by time. All that means to say is like this is like feet. This would be feet per second. This would be feet per second squared. Okay, so again, they're going to give you an equation. Kinematics will give you an equation. They'll give you something like the position function, and then they're going to want you to find the velocity and acceleration. So you take the derivative. A lot of this is vocab. You got to know if I say when's a particle moving left and right, that is velocity. If I ask what's a max position, well, you got to find the critical points and endpoints. Critical points when the velocity equals 0, because it's the derivative position. And then you got to plug them into the position function. A big one, they'll say, hey, find a position at a certain value, let's say A. But you have velocity. The way you get the position when you have the derivative below it is you have the initial value with respect to y plus the integral, the initial value of x, to the point you want A of velocity. So if you want position but you don't have a position function, you have the velocity function, that's how you do it. The initial value they give you, plug it in, y here, x there, integrate from that initial value to the value you want of the velocity function. If they give you velocity, keep in mind this is movement. Right, so left and right. Is it moving left, right, up, or down? You just graph it. So you do a sign chart, or you graph it on your calculator, depending if you get to use it or not. Positive is moving right. Negative is moving left. Don't forget keywords, total distance traveled. If they say that it's a keyword, it means you want to integrate the velocity function with the absolute value. You just put that into your calculator. Total distance traveled that. If they ever say what's the speed, speed is just the absolute value of velocity. That's it. Now, a lot of times they'll say, is speed increasing or decreasing? That's different. So just speed itself, absolute value of velocity. Is speed increasing or decreasing? That's where you got to compare velocity and acceleration. If velocity and acceleration are the same sign, then it's increasing. If velocity and acceleration are different signs, that means they're working against each other, then it's decreasing. So acceleration, so what is it in general? It's all it is velocity increasing or decreasing. That's all it is. Velocity is, if your acceleration is positive, that means your velocity is increasing. If your acceleration is negative, your velocity is decreasing. That's all it is. So let's do an example. The particle moves along the y-axis with velocity given by this. So it's moving up and down. And which direction up or down is the particle moving at time 1.5? Y. So all we're doing for A is, right, it's about movement. So I'm plugging in my velocity. They give me velocity. Just plug it in. V of 1.5 equals 1.5 sine of 1.5 squared. Plug that into your calculator. If you get a positive, it's moving up. If you get a negative, it's moving down. That's all you have to say. B. Find the acceleration of the particle at time 1.5. Is the velocity of the particle increasing at 1.5? Why or why not? So acceleration, we're going to take a derivative of it. Now you can do it on your calculator if you have it. You can take the derivative by hand if you want. That'll be a product rule though. Right, so you take the derivative of the calculator, and they want to know is velocity of the particle increasing or decreasing. That's literally what acceleration means. It's velocity increasing or decreasing. So same idea. If you get a positive, then your velocity is increasing. That's what acceleration means. If you get a negative, your velocity is decreasing. All it is. C. Given the yt is the position of the particle at time y equals 0 equals 3, find y2. So the thing I was talking about. You have velocity, they want position. So the way we're going to do this is this. You want the position at 2. You're going to add the initial value of x plus the initial value of y. The y value, the initial value. X value, the initial value. To 2, and we're going to integrate velocity. So in this problem, my initial value is 3. And we're going to go from 0 to 2 of velocity. Plug that into your calculator, get an answer, and that's your position. D, find the total distance traveled by the particle from 0 to 2. Total distance traveled is that key word where it just means you integrate absolute value. So all we're going to do is we're going to integrate the absolute value of velocity from 0 to 2. Plug that into your calculator. That's all it is. Let's do another one. This one from 2003, another velocity question. And then look at, here's our initial point. At time equals 0, the particle's position is 1. So they're saying x equals 1. I didn't mean to cross it out right there. So that's my initial condition. They're saying, hey, x of 0 equals 1. That's your initial position. A. Find the acceleration of the particle at time equals 2. Is the speed of the particle increasing or decreasing at 2? Why or why not? So acceleration, again, you have a calculator. So if I want the acceleration, all I gotta do is take a derivative of time at 2, which is equals the acceleration of 2. And there you go. Is speed increasing or decreasing? So remember, if you want to compare speed increasing or decreasing, then all you gotta do here is compare phi of 2 and a of 2. Plug them both into your calculator. If they're the same sign, it's increasing, speed's increasing. If they're different signs and working against each other, it's decreasing. Done. B. Find out times on open interval when the particle changes direction. So when something changes direction, it means the velocity equals 0. Stop for a second. So all we're going to do is set the velocity equals 0. That looks super hard right there, right? I can't do that by hand. I can't do it by hand. Well, maybe I can. What we do is use our calculator, we graph it. So you graph it, and anywhere it crosses, it changes direction. So let me do this. Right, so right here would be a critical point where it changes direction. Right here would be. This wouldn't count. It didn't change direction. It just stopped for a second and moved. So it'd be these two guys. So then you get your critical points. Let me look at the actual values. And actually the real one only crosses once, and that's at 2.506. The real graph. I was just trying to give you an example there. And actually, by the way, looking at it, it wouldn't be that bad to solve to set equal to 0. You could split it, and then you get -1, which doesn't make any sense. So that doesn't work because it has to be bigger than 0. And then you could solve that, and you get like rad 2 pi. Like, it's not the worst thing, actually. Anyway, C. Find total distance traveled. Again, keyword. That's its formula in your formula sheet. All you can do is integrate velocity, absolute value of velocity from 0 to 3. Put that in your calculator, and you're done. D. During the time interval 0 to 3, what is the greatest distance between the particles and the origin? Show your work, leads your answer. So that's another way of saying what's absolute max or min. Now in this case, it means either, because it's the distance between the particle and origin. So it doesn't matter if it's really to the right, which is the max, or really to the left, which is the min. Just the biggest of those two. So it's max or min, whatever is the biggest. So it's an absolute value problem. And with absolute max or min problems, we do critical points plus endpoints. Now my critical point we found already actually was when it stops moving. So 2.506. How lucky. And my endpoints, they asked me between 0 and 3. Now again, so I want to find the greatest distance. So what position is the furthest? So I'm going to use my position equation again. The one we did. We're going to find the position of each one of these. Like, which is the furthest along. So we have to do that special formula where we go, okay, if I want the position at 0, it's the initial value plus the integral from my initial value to 0 of velocity. My initial value they gave us was 0, 1. So this is 1 and that's 0. So my initial value is just 1. P of 3, it's going to be my initial value plus the integral from 0 to 3 of velocity. You get some number. And then we're going to do P of 2.506. So my initial value plus the initial value to 2.506 of velocity. And then, again, whichever one gives you the biggest difference is your answer from the origin. That's that one. And that's still working into your answers, all that right there. Let's do one more. So this one, again, they give you velocity one more time. They love to give you velocity. Particle moves on x, so the velocity is given by that. The particle position is x equals 8 at time 0. So they're using x as position in this case. So when I plug in 0, I get 8. That's its position. It starts at 8. Find the acceleration at time 4. So again, acceleration, I got velocity, just take a derivative. Just put that into your calculator, and you get an answer. B, find out time to open interval when the particle changes direction, during which intervals does the particle travel left. So kind of two questions here. When does it change direction? That's when the velocity equals 0. When is it traveling left? That's when it's less than. That's when it's negative. So if you have a calculator, you can just graph it. Let's say something like this. I'm just making it up. Again, I don't care about this because I only care about 0, 1. So it'll be there and there. When does it go left? From here to here. So you just got to graph it. I don't have the graph with me, but that's the idea. So all we're going to do is we're going to graph v of x, v of t on our calculator. And again, so where it equals 0, like here and here will be where it changes direction, and where it's going left is where it's negative, so there. If you don't have a calculator, it's actually not too bad to solve by hand. Like if you want to solve this by hand, it'll be natural log of t squared minus 3t plus 3 equals 0. Take the e of both sides. Because again, I'm trying to find when velocity equals 0. That's all I'm trying to find. And I have velocity. That e to 0 is just 1 equals t squared minus 3t plus 3. So I'd get t squared minus 3t plus 2 equals 0. So you get t minus 2, t minus 1. So t equals 1 and 2. So if you're going to do by hand, it's 1 and 2. That's where it changes direction. How would I figure out if I had to do by hand where it's negative? I would do a sign chart. So here's 0, here's 1, here's 2. And then we go all the way to 3, but who cares? Pick a test point for each one, like 0.5, 1.5, and 3. Plug in, remember, all you care about is the sign. So if I plug in 0.5, I get a negative, and I get a negative. Negative times negative is a positive. Plug in 1.5, I get a negative, and I get a positive, so it's a negative. Plug in that, you're going to get positive both ways. So from between 1 and 2 is where it's turning left, and then where it stops is 1 and 2. Find the position of the particle at 2. So again, we talked about that. It's one of my new favorite formulas. If you want the position, you have velocity. All we're going to do is the position, I guess in this case it's x, of 2 equals the initial value plus the integral from the initial value. I'm talking about x here, I'm talking about y there, to 2 of velocity. So again, our initial value here was 0, 8. So this will be 8 plus the integral from 0 to 2 of velocity. Plug that into your calculator, or if you're doing it by hand, you got that probably gave you a calculator. So they're not going to make you do that by hand. But that would be your answer. D, last one. Find the average speed of the particle over the interval. So average speed. So average anything, you integrate from 0 to our value, 0 to 2. And then we're going to divide by the limits of those. Now speed, I talked about a little earlier, is the absolute value of velocity. So that'll be my equation. Put that into your calculator, get an answer. By the way, before I forget, right, if you want average velocity, there's two ways to do it. You integrate your limits of velocity from 1 over the difference between your limits, or you got to do the one above it. The one above it. Just do the normal slope with the one above it. So displacement. So s of b minus s of a for b minus a. If you want average Excel, you could again just do the same integral but for the acceleration. So integral. Or you could do the one above it, which in this case would be velocity. So velocity of b minus velocity of a. B minus A. And that's it for kinematics.